Hey guys, today we'll talk about transformation of functions. Again, this is mostly review from 9th and 10th grade. I will go over it. So if you have a positive k added to the function, then it moves the graph up. If it is a negative k, it moves the graph down. I hope you saw this yesterday in the worksheet that you used. If you have the k that's added to x value inside the function, moves the graph to the left, and if it is a negative k, moves the graph to the right. So just to note that on the x, it kind of always does the opposite from what it does on the y. If you have a negative before the function, that reflects that function over the x-axis. Remember, this is the x-axis. And if you have a negative inside the value on the function, it reflects that function over the y-axis. If you have a constant value before the function and that value is less or greater than 1, that value stretches the graph vertically. If that value is between 0 and 1, then it's going to compress it vertically. So this is a vertical compression, but you can call it a horizontal stretch, or this is a vertical stretch, but you can also call a horizontal compression. Or both of them are of this original function. If you have a constant value before the input value, and that value is less or greater than 1, this is what I was talking about before, it compresses it horizontally, and if it is between 0 and 1, then it's going to stretch it horizontally. So this is a horizontal stretch because it is between 0 and 1, and this is a horizontal compression because that value is greater than 1 or less than 0. Let's try this example. I have fx is x minus 2 squared minus 1. I'm going to remember the definition of the function. So the initial function would have been fx equals x squared, and that initial function, if I were to graph it, would have been this function. You guys know it's just the graph of x squared. This is what it would have been, like that, right? But this negative 2, I know, moves that graph 2 units to the right. Let me use blue. It moves it 2 units to the right, so now it's going to start here and go up there, and then again pass through this point, which is this point, and then go that way. So that's when it's just x minus 2 close bracket squared. However, it is x minus 2 close bracket squared minus 1. That means it's moved 1 unit on the y-axis downward. So now it's going to be here, again we'll pass through here and pass through there, and the next point it will pass through will be this point, and again this point. So that's the graph in red. This is the actual graph for this function, but I was just showing you the process of how it gets there. Now it's the same graph that I just graphed because I have graphed this. I graphed that and it was this function. This is what I graphed earlier. So now they're telling us that this negative means it's reflected over the x-axis. So that will mean it's inverted. It will have, it's looking like a U, but this time it will look like an N. And this 5 means that it is compressed horizontally or that it is stretched vertically. So I know that when my x value was, for the first x value, this was 1 from the initial function, but right now I can't expect this graph to go here. I'll expect that value to be multiplied by 5, this value of the function to be multiplied by 5. So I'm going to look for the next point 5 units below this. So instead of just going 1, 1, I'm going to go 1, 2, 3, 4, 5. That's where I'll expect my next y value to be. And the graph is inverted, so this is its shape. You guys can check with Desmos to see whether your drawings are correct. This function, now remember initially it's just the cube root function, because the parent function is a cube root function, which you guys know looks something like this, right? That's what it looks like, the parent function. But that cube root function, first of all, shifted 1 unit to the left. So function which passed through here instead will pass through here, 1 unit to the left. What else is happening is it is being stretched vertically. It's being stretched vertically. So if this, I know for this function, since it is a cube root function, let's do opposite. Since it's a cube root function, I know that when x is 8, the cube root of 8 is 2, right? And I also know that when x is 1, the cube root of 1 is 1. However, it's now being stretched vertically. So when you put the 2 before the fx, this will no longer be 2, this will be 4. This will no longer be 1, this will be 2. So I know that this function has been stretched, I've been told that it's been stretched vertically and it's been moved 1 unit to the left. So first of all, it's passing through this point, and where I would have had 1, x1, y1, where I would have had this point and this point, I don't have those anymore. This time I have that point here and that point right here. And then when x is 8, I think this is 8, the y value is going to be 4. So the next point is going to be over there, and the next point for this one will be somewhere this way. You don't have to show these points. I'm just doing it for the sake. What you guys are doing is simply drawing the sketch of the function. So this is what this sketch would look like. As long as your sketch, I think, has the x and y intercepts, you're fine. This function is being moved 3 units up on the y-axis. So 1, 2, 3. This is where it's going to be, and then that, and that. Yep. Gx is f of negative x. Now remember, this negative of x means that function is being reflected over the y-axis, right? This is the y-axis. So it's being reflected over that axis. This point will instead be the same number of units on this side of the axis, on this side. This was 1, 2, 3, 4 units. It will still be 1, 2, 3, 4 units. This point above it, 3 units. This point above it, 2 units. This point, 1 unit. This point remains. This point right here is going to be this way, 2 units. This point that I'm pointing on is going to be, this point right here is going to be this way, 3 units. And this point will be this way. So the function is now looking like this, because it's being reflected over the y-axis. Right now, remember, this means, well, let's start with what's inside, sorry. Undo. This means that the function is being stretched vertically, or, yeah, it's being stretched vertically. So here I have x is 0, y is 2. This time I have x is 2 times 0, right? Or x is 2 times 1. So it's going to be, remember, that means, what does that? That's a horizontal compression. So it's going to be compressed vertically, horizontally. Horizontal compression is going to happen to this function, and then it's going to be moved 5 units down. So if it's going to be compressed horizontally, then it would be just this, just that, and just this. And then that section of that function is going to be moved 5 units down. So 1, 2, 3, 4, 5, and I have over there, here, and there. Yeah, so you follow the order of operations, starting with what's inside, and then you go to the last part. Okay, so this is your homework. There are 4 worksheet questions on worksheet 1 something. I think it's 1 4, sorry. Yeah, do the 4 questions. It's on page 21. It's the same page as 22, and then do the homework questions. Bye.